Hi everyone. In this video we shall see the topic sampling distribution and estimation. First let us see what is population. A population consists of collection of individual units which may be persons or experimental outcomes whose characteristics are to be studied. A sample is proportion of the population that is studied to learn about the characteristics of the population. Next, random sample. A random sample is one in which each item of a population has an equal chance of being selected. Next one is sample size. The number of items selected in a sample is called sample size and is denoted by n. If n is at least 30, then the sample is called large sample, and if n is at most 30, then it is called small sample. Sampling distribution. A sampling distribution is a probability distribution of statistics obtained from a large number of samples drawn from a specific population. Next one is standard error. The standard deviation of the sampling distribution of mean is called the standard error and is represented by the symbol sigma x bar and is defined as sigma by root n. Now let us see the notations. Population size is represented by capital N. Sample size is represented by small n. And the population mean is represented by mu. Sample mean is represented by x bar. Population standard deviation is represented by sigma and for the sample it is represented by S. Population proportion is denoted by capital P whereas sample proportion is represented by small p. Now let us see a problem based on this. The time between two arrivals in a queuing model is normally distributed with a mean 2 minutes and standard deviation 0.25 minutes. If a random sample of size 36 is drawn, what is the problem that the sample mean will be greater than 2.1 minutes? In problem, it is given that the population is normally distributed. So the sampling distribution of sample mean will follow a normal distribution whose mean is represented by mu x bar, which is mu equal to 2, and the standard deviation is sigma x bar, which is equal to sigma by root n, which is 0.042. Now, the probability that the sample mean will be greater than 2.1 minutes is P of x bar greater than or equal to 2.1. This normal variate x bar must be converted into a standard normal variate, which is given by P of x bar minus mu by sigma by root n, which is greater than or equal to 2.1 minus mu by sigma by root n. Now, x bar minus mu by sigma by root n can be represented by z. So, we have P of z is greater than or equal to 2.38, which is equal to 0.5 minus P of z less than or equal to 2.38. Now, by using the table value, we have P of 0 less than or equal to z less than or equal to 2.38 value is 0.4913. So, we have the probability value as 0.0087. It means 0.87 percentage of all possible sample of size n 36. The sample mean will be greater than 2.1 minutes. Now let us see one more problem. A random sample of size 9 is obtained from a normal population with mean mu equal to 25. If the sample variance is equal to 100, find the probability that the sample mean exceeds 31.2. In question, the mean mu is given as 25 and the standard deviation, that is the sample variance, is given as 100. So we have S square equal to 100, which means sample standard deviation is S is equal to 10. Now sigma x bar is S by root n, which is equal to 10 by root 9, and so we have sigma x bar value is 3.33. So, the probability that the sample mean will exceed 31.2 is P of x bar greater than or equal to 31.2. Now, the normal variate x bar must be converted into standard normal variate. So, we have P of x bar minus mu by S by root n is greater than or equal to 31.2 minus 25 by 3.33. Now, the value x bar minus mu by S by root n can be replaced by Z. So, we have P of Z greater than 1.862, which is equal to 0.5 minus P of Z less than 1.862. which is 0.5 minus P of EZ less than 1.86, which is equal to, from the table value we have P of 0 less than EZ less than or equal to 1.86, value is 0.4686. So P of EZ greater than 1.8862, value is 0.0314. Thank you.